In our previous lectures, we have seen what's a Bernoulli's differential equation. Now, I am a very strong believer that once you remember or once you learn a particular concept, the next thing that you should be doing is very quickly solve some questions, some examples on that particular concept. So, we have learned Bernoulli's differential equation of two different types. So we are going to see some examples on both the types, the differential equation of the Bernoulli's differential equation of the first type and the Bernoulli's differential equation of the second type also. Now, let us take one example over here, which is y raised to 4 dx is equal to x raised to minus 3 by 4 minus of y cube x dy. Now, a lot of times what happens is people will ask questions, how do we identify what question belongs to which type? Now, the basic strategy that I apply is whenever I get an equation, whenever I get a question, you should always start from the reverse order. Now, we have seen the entire differential equation, isn't it? We have seen the entire chapter. We have learned every single concept that is present in this particular chapter. So, we know what different types are there. So first thing that you should be doing is first thing that you should be doing is understand the question whether it is of the Bernoulli's differential equation. If it is not Bernoulli's, go to its previous type, which is reducible, means a given differential equation whether it is reducible to a linear differential equation. If not, go to linear differential equation. If not, follow the four rules, the rules that we have learned in our previous lectures. So that means whenever a question comes, my first target, my first approach must be to check whether the given solution belongs to Bernoulli's differential equation or not. Only then I'll be going further. Now, that's my question. Now, if I observe this question, it very much resembles mdx plus ndy type. But then I have to keep on checking all of the four rules. I'm going to solve this question not by the four rules, but by the Bernoulli's differential equation. Now the next question that might arise is whether to take dx by dy or dy by dx. See, if I take this equation as dy by dx comes in the right hand side in the denominator, dy by dx. That means this entire very big term will go in the denominator. So if this entire big term goes in the denominator, it becomes very difficult to arrange the terms, because this will become y raised to 4, which is single term, let us say a, upon this entire term which contains say b and c. So it becomes a upon b plus c. Now we all know the basic rules of mathematics. A upon b plus c cannot be separated. But if it becomes a plus b upon c, it can be very easily separated. So that is why I am going to transfer dy on the other side here, the left hand side, and y raised to 4 on the right hand side. So that would give me a plus b upon c. So that is how I have judged that this particular question has to fall into the second type of differential equation, the Bernoulli's differential equation. So I am going to write that equation somehow like this. I write dx upon dy is equal to, now this y raised to 4 is going to go in the denominator. So this is your right hand side. Y raised to 4 is going to come in the denominator. So I'm going to separate the terms as well. I get x raised to minus of 3 by 4 upon y raised to 4. That's my first term. And again y raised to 4 comes in the denominator. I get minus of y cube divided by y raised to 4. I get x upon y. X upon y. Got that? Now, if you recall the basic type of the linear differential equation, it says dx by dy plus p dash x is equal to q dash. So p dash x is what you see in your linear differential equation. So here also I have x raised to some power and then there is x. So it is very easy to identify that this is the term which I am going to transfer on the left hand side. That means I can write dx by dy and then I write plus, because it was with the minus sign, comes on the left, becomes plus 1 upon y into x is equal to 1 upon y raised to 4 into x raised to minus of 3 by 4. Now, we also remember dx by dy plus p dash x is equal to q dash. Q dash is only a function of y. Q dash is a function of y. So I can observe over here, I have 1 upon y raised to 4, which is a function of y. But it also contains contains x raised to minus 3 by 4. So my first job is to get rid of that x raised to minus 3 by 4. So if I want to remove this x raised to minus 3 by 4, let's see what can be done. Obviously I am going to divide throughout by x raised to minus of 3 by 4. So when I divide the entire equation by x raised to minus 3 by 4, what do I get? See, division by 1 upon x raised to minus 3 by 4. See, you are dividing by 1 upon x raised to minus 3 by 4. So it looks like 1 upon a raised to minus m. So goes in the numerator and I get x raised to 3 by 4. I hope you have understood this step. See what I did. It was 1 upon x raised to minus 3 by 4. So x raised to minus 3 by 4 will go in the numerator and become x raised to plus 3 by 4. So that's x raised to 3 by 4. And then dx by dy. Then plus 1 upon y, then see, x power is 1, you are dividing x raised to power 1, you are dividing by x raised to minus of 3 by 4. So again this 3 by 4 will go in the numerator and give me x raised to 1 plus 3 by 4, the basic law of indices. A raised to m upon a raised to n is a raised to m minus n. So m, which is 1, minus n, which is minus 3 by 4. That's why plus 3 by 4. So it simply comes x raised to 7 by 4. That means this term is going to be, so otherwise you have observed very carefully what has happened in the next term. It was x divided by x raised to minus 3 by 4. It has become x raised to 7 by 4 is equal to 1 upon y raised to 4, because the right hand side definitely got divided by x raised to minus 3 by 4. Now the right hand side has only become a function of y. The right hand side is only a function of y, which is my requirement. It's called my demand. Now if I look at this equation, I have a problem with x raised to 7 by 4. I'm going to get rid of it by using substitution. So let's substitute x raised to 7 by 4 as v. And you should definitely remember your independent variable is y. You are going from x into a new variable v. X is your dependent variable. If x is getting changed into v, so does dx by dy will also change. It will transform into dv by dy. That means I should differentiate this equation. Let's differentiate this equation, both sides, with respect to, very important, with respect to y. So when you differentiate x raised to 7 by 4 with respect to y, see what you get. So x raised to n, I get 7 by 4, n, x raised to n minus 1, x raised to 7 by 4 minus 1, 7 by 4 minus 1, again becomes 3 by 4. This is the term of x. We are differentiating with respect to y. So I get dx by dy is equal to dv upon dy. One final thing that I should be doing is removing the constant from here. The 7 by 4 has to be removed from here. If you observe your differential equation, it contains x raised to 3 by 4. You have got x raised to 3 by 4. Then there is dx by dy. You have got dx by dy. So what needs to be removed is 7 by 4. Not a problem. Set it on the right hand side. It becomes 4 by 7. So therefore I can from here say x raised to 3 by 4 dx upon dy is going to be 4 by 7 dv upon dy. So when I go back to my equation, this term I have got a replacement, this term I have got a substitution. So this differential equation, if I name it as equation 1, so this equation 1, this differential equation will now become, look at the replacements, this is going to become 4 by 7 dv by dy. So let's write 4 by 7 dv upon dy, then plus sign, 1 by y. This is taken as v, so 1 upon y and v is equal to 1 upon y raised to 4. That's your right hand side. So write 1 upon y raised to 4. Now what you need to do is simply multiply 4 by 7 throughout the equation. So 4 by 7, if I want to get rid of this term, because the linear differential equation, the differential coefficient should always and always be alone, never accompanied by any constant, any function, nothing. It should be alone. So remove 4 by 7 from here. And how do I do it? Multiply throughout by 7 by 4. So I get dv upon dy plus 7 by 4 y into v, 7 by 4 y raised to 4. Now people, I hope you have definitely realized this looks like dx by dy plus p dash x is equal to q dash, where p dash and q dash are both functions of y. See, p dash and q dash are both functions of y. So this is what you can observe in this particular equation also. Now, we all know the integrating factor is given by e raised to integration of p dash. When you compare this equation, your p dash value is 7 upon 4y. So I write e raised to 7 upon 4y dy. Isn't it? 7 by 4 constant goes outside. So write e raised to 7 by 4 integration. See, 7 by 4 has gone outside the integration. What is left is 1 upon y. We all know that integration of 1 upon x, it is log of x. So 1 upon y integrated with respect to dy will definitely give us log y, which in the next step I can obviously write e raised to log of y raised to 7 by 4. I have used the basic rule of logarithms. M log a is log a raised to m. So log a raised to m. Again, we all know, again a very simple formula, e raised to log of x will give us x. E raised to log of this number will be the same number here. That means I get y raised to 7 by 4. So that's my integrating factor. Now, once I get the integrating factor, the next thing becomes very simple. The final step, I need to find my solution. So to get the solution, we all remember the basic formula for solution. It's the dependent variable. Do we remember? In our case, the dependent variable is v. I have a different variable, which is v into the integrating factor, which is y raised to 7 by 4, is equal to integration of the right hand side. The right hand side in our equation, that's q dash. The right hand side is 7 upon 4 y raised to 4. That's the right hand side. Multiply with the integrating factor. So integrating factor, look at this, y raised to 7 by 4. Y raised to 7 by 4 dy plus c. So initially I am not going to write c, I am going to write c dash. There might be a possibility that some constants might also appear. So I am going to write c dash at the beginning. Now let's simplify it here. This is a raised to m upon a raised to n. A raised to m upon a raised to n. The law of indices, a raised to m minus n. The constant 7 by 4 goes outside the integration. So let's remove the 7 by 4 outside the integration. A raised to m upon a raised to n becomes a raised to m minus n. So it's 7 by 4 minus 4. Let's do it somewhere here. 7 by 4 minus 4. So that's 4 into 4, 16. 7 minus 16. I get minus 9 by 4. So I've got minus 9 by 4. So that means, so here I'll be getting y raised to minus of 9 by 4. Y raised to minus 9 by 4 and then dy and plus c dash. Again, everyone remembers how to integrate x raised to n. The integration of x raised to n is x raised to n plus 1 upon n plus 1. So I'll be getting v into y raised to 7 by 4. See the left hand side. V into y raised to 7 by 4 is equal to again 7 by 4. 7 by 4. X raised to n. Answer is x raised to n plus 1 upon n plus 1. So I write here y raised to minus 9 by 4 plus 1. So minus 9 by 4 plus 1. So that's 4 1 to 4 minus 9 plus 4 gives me minus 5 upon 4. So I'll write here minus of 5 upon 4. Is that right? Minus of y raised to minus of 5 upon 4. This is the integration. Upon minus of 5 upon 4. We don't know the formula. X raised to n integration is x raised to n plus 1 upon n plus 1. And I'll write plus. Initially always we give c dash. We can very well observe that 4 and 4 gets cancelled over here. This minus 5 can be multiplied throughout the equation. So I get, see this minus 5 can be multiplied throughout the equation. So I get minus 5v y raised to 7 by 4 is equal to 4 and 4 has cancelled. Minus 5 has gone on the left hand side. We are left with 7 y raised to minus of 5 by 4 plus c dash. Now see, you are multiplying throughout with minus 5. Throughout by minus 5, we are multiplying throughout by minus 5. The constant will also get multiplied with minus 5. I get a new constant. So I write c2. C dash was my previous constant, so or you can say C1, and it is getting multiplied with the new number -5, so it has given me a new constant C2. The final and last thing that I should be doing is simplifying, and always remember to replace your V back into the solution. If you recall, go back, V is x raised to 7 by 4. So never ever forget. Always remember to replace your V back into the solution. So finally I'm going to get my answer as minus of 5. V is x raised to 7 by 4. So V is x raised to 7 by 4 into y raised to 7 by 4 is equal to, look at the other change, y raised to minus 5 by 4 looks like a raised to minus m. You can bring it down and write 7 upon y raised to 5 by 4 plus you can write C2. One last thing that you should be doing is take the constant on the left, take the constant on the left, take this term on the right, take the term which is on the left with the negative sign on the right, take the constant which is on the right hand side to the left, rearrange the terms, it will look like this. This has gone on the right, so plus 5, gone on the right, plus 5, x into y raised to 7 by 4, gone on the right you have this term already, so plus 7 upon y raised to 5 by 4 equal to, constant is taken on the left side, has become minus of C2, can be called as a new constant C. So that's how you can solve example, it's an example on Bernoulli's differential equation of the second type. I hope you have understood this particular question very properly. I would strongly recommend to try and solve as many questions as you can on the second type of the Bernoulli's differential equation. Thank you so much.